All right, so we're going to start chapter 8 today. So chapter 8 is arrays. Now, arrays are something like a data structure that we're going to use for Java 3. So like knowing how to create arrays and insert data and stuff like that. Something going to be important, like in chapter 12, I think, is when we start sorting and all that. And yeah, but anyways, like you have to know how to like use arrays and how they work. So just because like in data structures, like that's going to be the primary way of storing and manipulating data. Okay, I did go over this with my Java 1 class, but I'm going to go ahead and just read through all the slides like if I was teaching it for the first time. And I'm going to show you like a few things. I'm just going to make the assumption that we know nothing about arrays. Okay, so I'm just going to take it from the top. We're going to talk about the first 4 sections in chapter 8. So we are going to stop, like we're going to cover 2-dimensional arrays, and then we're going to move on to the next chapter. It'll probably take me like 2 class periods to finish chapter 8, just because, I mean, I want to do examples and stuff like that. All right, so declaring arrays. Okay, the array list class introduced in chapter 5 is used to organize a list of objects. It is a class in the Java API. An array is a programming language construct used to organize a list of objects. It has special syntax to access elements. As the name implies, the array list class uses an array internally to manage a list of objects. So technically, the array list class is really just managing an array. So whenever you add an item, it's like recreating a new array and moving all the data over so that it can fit data inside of that array. An array is an ordered list of values. That's a lie. Well, I don't know how they mean ordered, but I guess maybe they mean ordered by the index, but definitely not the data. Like this data inside of an array can be out of order, right? You see how it's 79, 87, 94, 82, 67. I don't know why they said ordered list. Maybe they just mean like because you start at index 0 and then go on to the size -1. Okay, so an array is an ordered list of values. The entire array has a single name, so the name of this array is scores. Each value has a numeric index, so every array is going to have an index of where you can use to access data at that particular spot in the array. An array of size n is indexed from 0 to n-1. So when you declare an array, you say how many items it can hold. So let's say we declare an array of size 10. That means its max index is going to be 9, and its lowest index is going to be 0, which is 10 items, right? So they start from 0, they end of 9. There's 10 items inside of this array. A particular value in an array is referenced using the array name followed by the index in brackets. For example, here's the expression to get data in scores at index 2. I'm gonna hop back over here. Index 2 has a value 94. So when we say scores at index 2, there's actually a value there, which is whatever value is contained at that index. In this case, it refers to 94, which is the 3rd item in the array, because you start at 0, so index 2 is actually the 3rd place. That expression represents a place to store a single integer and can be used wherever an integer variable can be used. For example, an array element can be assigned a value printed or used in a calculation. So here they're assigning a value to a location in an array, and then they're using that. What are they doing here? Oh, then they have this variable name for, I guess, integer, which is some integer. I don't know what location that is, but it is an int. So they're assigning this element in the array whatever value it contains plus 2, and then they're figuring out the mean by taking the value at index 0 and adding it to index 1, dividing it by 2, and they're saying top 5. Like, they're just doing a bunch of random stuff here. Maybe I should just do a demo at this point. All right, so I'm gonna just use Notepad++ to demo this. So I'm gonna save this as, and I believe I'm in Java. Yeah, I'm a Java 1 folder. All right. Dang, there's a lot in here. Okay, I'm going to make a demo called Array Demo. and save. All right, so public class, the name of my class, and then I need my main method, public static void main string array arguments. Okay, so when it's time to declare array, you have to specify the data type. It can hold an object, so you can make an array that hold an object. An array can also hold primitive data, so I can also make an array that holds primitive data. So if I want an array that's going to hold integers, I'll declare the data type, I'll use the square brackets, and then I'll give my array some name. And the name that they use is scores. And then I'm going to have to say new. I'm telling Java that this is a new object that I want to instantiate and put into memory. And then I'm going to have to specify the data type and these square brackets and how many items this is going to hold. Okay. So right now I just created an array that can hold 10 items. Okay. I can iterate over this array with the for loop that we learned in chapter, I don't know, what is it, 6, right? Because they like for int I is equal to 0 while I is less than. Now arrays are an object, even though it holds a primitive data type. Okay, so even though it's holding primitive data, it's an array itself is an object. So there is a parameter that you can call on an array called length. Now when I say parameter, I didn't say method. So there's no open close parentheses at the end of it. It's just length, right? It's just what we call a actual parameter, not a method. And then in this loop, I'm going to increment I for every iteration. And then I can just do something like, let's see, system.out.println and say something like, I don't know, x plus, or no, I'm not using x, I'm using I plus, and then print out whatever values stored in this location. So the value stored in this location would be scores at index I. And that's going to iterate over the size of the array and print out every value inside of this array. So let me open up command prompt. All right, so I'm going to compile.
It's not there yet.
Is it? Not there.
It was just saying because of the array empty.
Right, yeah. So I wanted to show, like, I didn't assign any data into the array, right? I just wanted to show what happens if I didn't do that. Okay, so then I'm going to run. Okay, and it's all 0, right? It was kind of interesting, though, because all the other times when I tried to use a variable and I didn't assign it any data, Java would get upset at me, right? But for an array, like, since it's an object, it's that information is kind of hidden away from Java. So the compiler is just like, oh, I don't know what to do. And default values will get assigned 0. Okay, so just keep that in mind. Like, if you don't actually assign it a value, the value there would be 0. But if I were to do something like this, and I'd say like num, and I try to use num like down here, then Java's going to get upset at me. It's not even going to compile because I'm trying to use a variable that hasn't been initialized, which is kind of interesting to me. I don't know why it just doesn't compile and let you use 0. I have no idea. Like, why does it have to be strict sometimes but not so strict the other time? All right, so I created this array. I didn't initialize any of the data, and I printed out the values, and they're all 0. If I wanted to assign, let's just say I wanted to assign one of the values to one of the indexes, like I want to assign index 2, which is the 3rd spot, the value of 94, I can just do it like that right there. Okay? And scores 2 is a number, so I can do like mathematical things with it. So let's just say if I wanted to assign scores at index 0, whatever index 2 is, multiplied by 3. Okay? Now I'm assigning index 2, the value stored at index 2, or excuse me, index 0, the value stored at index 2 multiplied by 3. Okay? Now if I were to iterate over this array again to print out all my data, you can see that those values were updated, index 0 and index 2. Oh, you know, it's not going to compile because I still haven't initialized this up here. All right. How about over here? Clear my screen, compile, and run. Okay. And I should have put like a system, some type of space because it looks kind of funky. But there's the first time I printed out my array, right? 0 through 9, all zeros. And then here is the second time I printed out my array. At 0, I have 282, and at 2, I have 94. Okay, so an array is essentially just a container of items that have a defined data type and size. Once you define the size of an array, you cannot change it. Okay, so if I wanted to grow my array, we'll talk about that whenever we get to for the end of this semester. But wanted to, like, just say I filled up all 10 items and I want to add an 11th one. I would have to make a new array that holds 11 items and then move everything over to my new array. Yeah, that's the way the array list works. All right. So the other thing I want to talk about before I go on to the lecture, or hop back to the lecture, is we have this here in our main method, right? So our main method is actually taking in an array of arguments. Okay, so there's actually an array being passed into our main method. I can do something like this. I'm going to move everything down, and that way I can do all my work up here. I can say something like system.out.println print line, and say args length is, and args dot length. Okay. Some of the other things I can do is I can iterate over this. I can say for int I is equal to 0 while I is less than args dot length I plus plus. And then do something like I plus space args, and then print out args at that index. Okay. All right, so I'm gonna hop over to command prompt, to my screen. I'm going to compile and run. Okay, so I should put some space. Dang it, I keep thinking about it. But anyways, it said my args length is 0, and then it went on to print out the array of scores. All right, let me make this a little nicer because it's like super confusing to me when I see the output. So I'm just gonna do like a blank system.println right here, and then above my for loop, I'll just put like print scores, and above my other for loop, I'm going to do the same thing, but I'm gonna put like a new line character right here. And actually, I should probably do the same thing here, like print args. All right, looks better. Clear, compile, run. All right, so I printed my arguments, but there's nothing there because the length was 0. Okay, the way the arguments comes into play is it's strings. So whenever I actually run my program, I can pass what we call arguments. I can just, type some random string characters here separated by space. Right, doesn't matter what it is. Java's gonna treat it all like strings. Press enter, and now my args length is 9. And I iterated over that array, and this is all the data that I got. Right, so this is a way to pass in data into your program. Now this is actually used a lot whenever you're trying to pass, like you have different modes in your program. Just say like somebody's complaining that the program's crashing or they're doing this and that. So maybe you enter in the program that you created and pass in the argument debug mode, or maybe you do something like this, like mode debug. I don't know, something like that. And now you get this string going into your program. You can parse that out and know, hey, when I'm in debug mode, I want to print out more statements so I can see what's actually happening in my program. Like see what data is doing what, print out more information, because you're essentially running it in a mode to where you want more output. Okay, that's the way the arguments are used in Java. It's a way to pass in data into your program before you actually start it. Okay. All right, let me hop back over to the lecture. Let's see. So, for example, arrays. Okay, I demoed that. Okay. The values held in an array are called array elements. An array stores multiple values of the same type. Right. That's the element type. The element type can be primitive data or an object reference. Therefore, we can create an array of integers and an array of characters, an array of string objects, an array of coin objects, etc. Scores array can be declared as follow. Okay, they didn't actually show us how to declare it, but there you go. I mean, I did it before we saw this. The type of variable scores is an int array, an array of integers. Note that the array type does not specify its size, but each object of that type has a specific size. The reference variable scores is set to a new array object that can hold 10 integers. Okay, so whenever you put the bracket like that, it's just telling Java that it's not an integer, it's an array that can hold integers. Some other examples of array declarations. So here they're just giving you some array declarations. All right, so you can use the for each. So I've been using the for with the integer and 0 incrementing over every iteration. I'm gonna go ahead and read this slide though. There's something important that you need to know about it, but I wanna see if it touches it. So the for each version of the for loop can be used when processing array elements. So for int score in scores, system.println score. This is only appropriate when processing all elements starting at index 0. It cannot be used to set array values. Okay, that's the important thing I wanted to say. That the for each loop cannot actually set the array values. Okay, so if I were to use the for each loop, let's just say for the second time I print out the scores, I'm going to do this. I'm going to take whatever the score is at index I. I want to go ahead and set it equal to itself. Actually, I could just do plus equals to itself plus 5. Okay. Now I'm going to hop over here, clear my screen, compile, run. And you can see that I started adding 5 to whatever values were there. Okay. Now, if I were to use a for each loop, I would not be able to do that. The for each is 4, and then you make some variable that's going to hold some data. So we'll just say like score inside of my scores array. And I'll still iterate over the array, but I won't actually print out, or I won't actually save any data. The thing that sucks is you don't know what iteration number you're on. That's the other thing that kind of sucks about the for each loop. So I'm going to print out score, but over here I'm going to try to set score is multiplied equal to 10. I'm going to try to multiply it all by 10. And you'll see that it's not actually going to take. So I'm going to save, hop over here, clear my screen, compile, and run. And you can see that, dang it, oh, you know what? It took at that instance, but if I were to print it out one more time after, it didn't actually save into the array. Sorry, yeah, that's what it was. All right, so I'm going to print out the values again. So I'm going to say print scores using for each. Okay. And it looks like I changed my values, but I did not. And then here I'm going to say print scores using for each. I'm going to say and multiply by 10. All right, so now I'm going to clear my screen, compile, run. And you can see it looked like I modified my values because that variable score inside of that for each is a local variable that we actually modified, but it wasn't actually assigning the value of score back to the array. So, oh shoot, the values remain the same. So it's important to know that when you're using the for each loop, that you really only want to use it whenever you want to iterate and then process the data, meaning you're not actually trying to change the value inside of that array. All right, any questions on that? Make sense, right? kind of, not really, but I don't know. So just remember that about the for each loop, because I'm going to ask you on your midterm, like, what is the difference between the for and the for each, and you're going to have to know things like that. All right, so they did an example in the book, and this is an important one too. So whenever you go outside of the range of an array, Java is going to throw a runtime error, which is the array index out of bounds. It doesn't know it at compile time, so it will still compile. It just won't. It just doesn't. It won't process any further than where that runtime error happened. So, for instance, I just created a scores array, right? I said it was size 10, and I try to come over here and say, you know what? Go ahead and set scores at index 10. There's no index 10 because the highest index when you have 10 items is 9. Go ahead and set the score at index 10 to 15. Okay, at this line, Java is going to throw a runtime error. It will compile, it just won't run, or will run, but it's going to stop running at that point. So I'm going to clear my screen, compile, and run. Okay, so I was able to get a few lines out, but as soon as I declared that array and then I tried to assign a value at that location, we got the array index out of bounds. So you have to be careful when you're using arrays that you don't actually go out of bounds. That's why it's just habit for me. It's always good programming practice to use the array length if you're going to use a for loop like this. I could have just used 10 here, right? And I'm always going to iterate 10 times. But let's just say I go and actually change the size of that array to something smaller, then you have the risk of actually you will have that array index out of bounds. Okay, that's a runtime error. All right, here this slide just tells you that you should bounds check, right? Like here they're giving you the example that I just talked about where you're using 100, but it's better to actually use the length of the array. And what are they doing here? Oh, they're putting stuff out in reverse order. All right. Okay, so there's an alternate syntax to declare an array. Most people don't use it. So technically, you don't have to put the square bracket at the end of the data type. You can put it at the end of the identifier, right? But that's just not good programming practice. Most places actually have a coding standard that tells you to put the square bracket at the end of the data type. So Java will parse either one of these. It doesn't matter to it. Okay, you can declare an array like this or declare an array like this. Initializer list is actually really useful. Okay, so let me just start another example. I feel like I have too much going on in this one example. So I'm gonna make a new file and I'm gonna save it as array demo 2. Dang it, what the heck? I saved it as a text file. Nobody stopped me. Okay, let me see. Java file. All right. All right, so let's see what I'm going to do. All right, I'm going to just make an array, but this time I'll make an array of floats. I'm going to say float, and I'm going to say grades, and I can do something like float. Actually, I have to put the new here. Let's just say I have, 4 grades, and I'm going to say grades at index 0, and we'll just say 67.1f. I'm going to copy this a few times. Okay, so I have 4 of them, so my lowest index is 3. So 0, 1, 2, 3. I'm going to just change up some of these numbers. All right. And then I'm going to iterate over this list, but I'm going to use the for each loop because I don't plan to change any of the data. So I'm going to say float grade from grades. Okay, and I'll just do system, oops, system.out.println. All right, so I'm just assigning data, and then I'm just iterating over just the container and printing out all my information. Okay, so this is Java demo 2, or not the Java demo 2, array demo 2. .java, compile, and then run. Okay, pretty simple stuff, right? Declared my array and assigned the values. Now, if you have something like this where you just know what the values are actually going to be, then you don't actually have to assign them here. Oops, I'm thinking I'm in IntelliJ, dang it. All right, you don't actually have to assign them here. What you can do is make an initializer list, and I'll go ahead and just comment that out as well. I'll comment all that out, and then I'll just come over here and say float array grades is equal to, and then here's my initializer list, and all you do in this initializer list is you put in values that you want at those locations. So if I want my 67.1 at index 0, then I'll put it first, and then 78.18f at index 1, and 97.03f at index 2, and then my last index, I want the 84. I can do it this way if I know what values I want inside of that array. It's called the initializer list. It works a little different though whenever you have objects. But let me go ahead and come my screen, compile, and run. And oops, I ran the wrong thing, dang it. And run Java array demo 2. Okay, it ran just the same. Okay, but it was less code because I didn't have to like every line initialize these values. So if you do know what the actual values are going to be, you can do something like this. Okay, let me show you the way it works with an object. So new file, save as, and I'll call this one array. See, what do I have in here? Oh, I have a die. I'm gonna put some dies into an array. All right, so public class all right, so I'm gonna say I might have an array that holds die objects. I'm gonna call it dice, and I'm gonna say that is going to be let's see. I guess I'll roll 3 dice instead of the traditional 2. I'll slap a 3 in there. Okay, so let me go ahead and iterate this so we can see what the default is for an array whenever you have an object. So I'm going to say for int I is equal to 0 while I is less than the dice.length, I plus plus. So system.out.println, and I'll say I plus colon plus dice at index I. Save it. All right, so let me hop over here. So I'm going to compile. This is array dice demo, right? Array dice demo. Dang it, I have to put an I there. Now tab. All right, compile. And then run. Wait, what? I didn't put a main method? Public static. Wait, did I already do? Wait, I'm so confused. Oh, I already did an array dice. My class is called array die. That's weird. All right, so I'm gonna compile. Oh my God, what the heck is going on? Oh, thank you. Sorry. All right, compiles, and array die. All right, so I created an array to hold objects, right? I didn't actually assign objects to those locations of the array. So right now, that array is holding null in all 3 spots. So I don't know if you guys remember I don't know if I talked about this in Java 1, but somebody should have told you this at some point. If not, I guess it's a Java 2 topic. But null means that it's not pointing to anything in memory, right? So whenever you have an object, you put it into memory, and you have an object reference variable. That object reference variable simply has the address of where that object is located in memory. So when something is null, it just means that object reference variable is not pointing to anything. Okay, so it's not a die, it just doesn't know where to point. You said it was going to hold a die, but it's not pointing to anything in memory. So that's what a null is. It's very dangerous because, like, just say if you wanted to roll your dice, like right here, to say every time I'm going to iterate my list of die, and I want to call the roll method. Okay, now this is actually going to throw what we call a null pointer exception, because even though a dice lives in that location, or a die lives in that location, it's pointing to nothing. So that means it can't invoke that method on nothing, right? So you'll get the null pointer exception. Let me clear my screen, compile, and run. Okay, and it immediately crashed. I didn't have any printouts before that, but that's a runtime error. So as soon as I call roll, it just crashed. It's telling me on line 6, right? It's actually telling me where the error is at, and here's my line 6 right there. Okay. All right, so we have to initialize this. So to initialize this, we're going to say my array at index 0 is going to equal to new die. And index 1, index 2. Okay, so basically assigning those values. I'm assigning an object to those locations of the array. So now, let me try this one more time. Okay, and there you go. Like, that was me rolling my die and then printing out the value. If I wanted to roll this a few more times, I could just wrap this in a loop, another loop, right? You can do all kinds of crazy stuff with loops. So int x is equal to 0, while x is less than. We'll roll all 3 dice 10 times, x plus plus. And then I'll nest this for loop instead of a for loop. Okay, so the outside loop is just running whatever code's inside of it 10 times. And then the inside loop is iterating through the list of my die and rolling it. So I'm going to roll all 3 die 3 times. Let me put a system.out.println. That way there's some like separation in the prompt. Okay, so compile and run. And you can see that was me rolling the dice 10 times. Let me see where I'm at. Okay, this is the first time I rolled it. Second time, third, so on. I did it 10 times. Oh shoot, I'm moving too fast. All right. Okay, cool. Okay, so just say I know I need to have objects inside of that array. Okay, I want to make an initializer list like I did the other one. So I'm going to go ahead and comment out what I did up top. Okay. Now you can do the same thing what we did for the grades. We can say die, make an array that's going to hold die objects, call it dice, is equal to, and have an initializer list. And I forget how this works because I don't do it too often. But basically, you're basically calling the constructor 3 times, right? Because you want 3 die. Okay, and I believe. Okay, I'm gonna compile it like that. I don't think it's gonna work. I think I'm gonna need to do something like that. Or I don't know. We'll see. I'm getting my languages confused right now. Okay, so clear my screen and compile. It compiled. Dang it. I guess that is the way. Okay, compiled and ran. So that was me making the initializer list for an object. For some reason, I thought it was different, but I guess it isn't. Okay. And it's really easy too. Like, the benefit of this is if I use the other way to say I want to add 2 more dice, I would have to come over here, change that number to 5, and then do 2 more of these lines for index 3 and index 4. here, if I wanted to add 2 more dice, I can simply just put them inside of my initializer list, and now my dice array holds 5 die objects. So I'm going to compile and run. Okay, now I'm rolling 5 dice for every iteration of that loop. Right, so this is my 5 dice being rolled the first time, the second time, third, right, so on and so on. Okay, so that's the initializer list. It's actually pretty useful if you know what data you want to put inside of your array. All right, let's see, keep going. Okay, to give you an example of the initializer list. All right, arrays as parameters. I'm gonna have to read this slide because I don't read it that often. I don't know what it says. So an entire array can be passed as a parameter to a method, like any other object that references to an array is passed, making the formal and actual parameters aliases of each other. Therefore, changing an array element within the method changes the individual array element can be passed to a method as well. In each case, the type of formal parameter is the same as the element type. All right, so basically what they're saying is I can make a method that takes in an array, and if I make any changes on the array, because an array is an object, so you're getting an object reference, it's actually going to change the data inside of that array. That makes sense, right? Because an array is an object, you're giving it an object reference. So this method here, I'm just going to make a method called public static add 3. Okay, I can't think of anything clever. Okay, so add 3 is going to take in float array, and then I'll just say values. And if I said something like for int I is equal to 0 while I is less than values dot length I plus plus, and then for every iteration we're going to take our values, and at that index we're going to say plus equals 3. Okay, really simple. Okay, so down here what I'm going to do is I have my grades, I printed them out. Then I'm going to call the method add 3, and then pass in, I'm going to pass in grades, and then I'm going to print out my values. I'm going to say grades after add 3 call. Okay. So this is the array demo 2. Okay, so I'm going to compile array demo 2. And what the heck? Oh, dang it. Compile array demo 2. Dang it. Public static. Oh, I didn't give it a return type. I'm sorry about that. Public static void. And then I'm going to run array demo 2. Okay, so what happened was, here's the array, like from the initializer list. I called grades after add 3 call, and I passed my array to that method. That method actually modified my values. Okay, now it's different with primitive data types, right? A primitive data type will not get modified. So if I made a method called let's see, add 3 that just takes in a float. This is going to be like, I don't know how confusing this is going to be, but if I made this and I just said, okay, value plus equals value, or plus equals 3. Okay, I can say system out print line value in add 3 that takes a float, not the float array, and then I'll just do like plus value. Okay, I'm gonna print out the value when you make this call. All right, so I have two methods that are the same. I give them the same name. I know, like, I'm confusing you guys, but this is called overloading. So Java's okay with this as long as the parameter list is different. This one takes an array of floats. The other one just takes a float. Okay, float is a primitive data type. So that variable is not an actual reference to an object. It's an actual data type in memory. So whenever you're dealing with primitive data types, Java will copy the value over. So it's giving add3 a copy of that value. So it should not, and I say should not because I haven't tested this in a while, but it should not actually change the values in the array. Okay, so the first time I call it add3, I pass in the entire array. Okay, so what I'm going to do this time is I'm going to say for int I is equal to 0 while I is less than grades.length I plus plus, and I'm going to say add3, and I'm going to send in grades at index I. Okay, and then I'm going to output the value. I'm going to say grades after add3 float only call. All right, so let's see what happens. So I'm going to clear my screen, compile, and run. Okay, so let's see, here are the values when I actually call the add3 that takes in the entire array. Here are the values of add3 while I'm actually calling the method. So I'm printing out stuff inside of that method. So it's taking the value, adding 3 to it, and printing it out, right? It's actually doing it. That print's actually happening like right here. I just take the value, add 3, print it out. Okay, but you notice after I'm done with the call, like none of my values in my array actually changed. All right, that's another thing that's kind of, you need to understand. Primitive data types being passed to a method are copied over, right? But whenever you pass in an object, you're passing in a reference. So if that method changes anything in that reference, the object is actually going to change its value. Where primitive data is just copied over. The only real way to change that primitive data is if I were to remake this method to return, return in a void, I return a float, and then return the value of it being added to 3, then I would have to assign the value right here. After assign that location to itself after I called the add3, and then the value would get updated. Make sense? I don't, yeah, sorry.
It's just a pointer.
You said?
It's just a pointer.
Right, so object is always a pointer. So I don't know if you're familiar with C++, we don't have pointers and pass by reference, pass by value. Primitive data type is always pass by value. Any object reference variable is always passed by reference. Just remember that. C++, there's ways to do them both, right? I don't know what other programming languages are like that. But Java is just trying to make things easier, I guess. You don't have to worry about like all these different ways to create a method. But object reference, you get the reference of where it is in memory, so you actually make changes. Primitive data type, you're actually getting a copy of the data. Okay. All right. Let's keep going. Okay, so the next thing is the arrays of objects. I just talked about this, dang it. Okay, I'm going to talk about this. Because I did it with the dice. They're trying to show it to you with the strings. All right, so let's see if there's anything useful. Okay, here they talk about the command line arguments. I've already talked about that, so I'm just going to read the slide and not show you anything. The signature of the main method indicates that it takes an array of string objects as a parameter. These values come from the command line arguments that are provided when the interpreter is invoked. For example, the following invocation of the interpreter passes 3 string objects into the main method of the state eval program. Java, state eval, Pennsylvania, Texas, Arizona, and they give you an example of how that works. You can take a look at that. All right, variable length parameter list. I want to talk about this. This is fun. Okay, I'm going to read the slides. I'm just going to show you, and then I'll stop there, and then we can finish the rest of the chapter next week. All right, so let me make a new demo. What do I want to do? I need an object or something. All right, actually I can do it like in the same class. All right, so I'm going to call this one variable length parameter. This is actually like really cool, in my opinion. I don't know how you guys define cool, but I think variable length parameter lists are really cool. All right, so let me define my class and my main method. All right, so I'm just gonna, let me see, what am I gonna do? I'm gonna make like a string called name, and I'll just set it equal to Mike, and then maybe make an int called num, set it to 90, Boolean maybe? I don't know. Boolean called, oops, I didn't even give it a name, bool, and we'll just say false. All right, that's good for now. Okay, so I'm going to say system.out.println. And I'm going to say string.format. String.format is one of my favorite methods. And then I can just say something like %s for where I want to inject the string, %d of where I want to inject the integer, and I think it's %b for Boolean. And then I'll just say like name num bool. Like really simple. I'll come over here, clear my screen, compiles, that's always a good sign. Okay, and just print it out like those variables, right? Interesting. Okay, so let's just say I've made like I don't know, a float, and I'll call it like num2, and num2 is equal to 89.123f. Okay, and I went ahead and slapped it in here, and now I come over here and say %f. I added another parameter to that method, and I compile and I run, and I went ahead and injected that float as well. I could keep going and I could keep going, right? So just think about this. Whoever wrote this method format had to overload it. Is it overload? Yeah, had to overload it to take what, like two parameters, 3 parameters, 4 parameters. Like, you think they actually did that like for infinity? No, they didn't. Right? So in Java, we can define if a method is going to take a series of entries. The only thing is, let me see. Hang it. Wait, I already skipped it. I'm just going to look at an example real quick because for some reason I'm brain farting on this. All right. So what you do is you specify the data type and then use the 3 dots, and then like you give it like some identifier name, and that's pretty much like you passing in some array that is going to be of some variable length, right? So you're going to pass in like all this data into this method, and then you're just going to iterate through that list, and then you'll be able to do some type of work on it. Okay. So for instance, if I came down here and I made a method called public static float average, or find average, calculate average, cal average, I can make a variable length parameter list that takes in a bunch of floats. I'll say float, and then 3 dots, 1, 2, 3, kind of funky syntax, and I'll just say like values. And then what I can do is make a float called sum, and sum is going to be equal to 0. And then I can say for float val inside of values, I'm going to say sum plus equals val. Okay. and then I can just return my sum divided by my values that came in, length. Okay, it's an array. So now I can do something like this. I can say system.out.println, say average, and then call that method, calculate average, and then pass in a series of numbers. So I'll say like 45, 67, 89, and then the next time I run this, I'll just add a few more. I don't actually know if these, man, what the heck? Wait, I'm going crazy now. All right, then, yeah, all right. So save that, hop over here, clear my screen, compile, and run. Okay, and there's my average when I passed in 3 numbers. There's my average when I passed in, I don't know, how many is this? 3, 7. Okay, so you can make a method that takes a length of parameters. You're not actually taking in an array. You're just taking in a series of values that are going to be passed in. Now, the way this string format is done, it's actually taking in just objects, right? And the primitive data type can be an object, I believe, because of the wrapper class, like the auto boxing and all that. So actually, I don't know. Let me. So I'm curious now how this one is defined. So, or actually, I have the API open right here, and I'm already on. Yeah, I'm already on the Java.language package. So I'm gonna click string. I'm gonna search for format. Dang it, it's all the way over there. All right, well, let me just scroll down. Okay, yeah, so it's objects that it takes in. You guys see that? It's using a variable length parameter list, but it's taking in objects. Those primitive data types are being treated as objects. And then inside that method, I don't know what it's doing, but it's finding what type of object, like if it's a Boolean, if it's an integer, if it's a float, that type of thing. Okay, so that's variable length parameter list. I actually find it like really useful. I was always confused how this was done until I found out about variable length parameter list. All right, any questions? Okay, so our next class, I'll continue with arrays. I'm gonna read like all the slides in the variable length parameter section, and then we're gonna talk about 2-dimensional arrays, and I'll probably just do a few more examples, and then we can move on to chapter 9.